In this video I'll give a short introduction to the project and then demonstrate the features of the device. First of all, I should explain what a drum machine is. It's an electronic instrument that allows you to program in a drum beat and then play it back by triggering drum sounds in a rhythmic pattern. What makes this drum machine analog is that the drum sounds are synthesized from scratch entirely by means of analog circuitry. This is in contrast to digital drum machines, which typically work by playing back recorded samples of drum sounds from memory. Here are a couple of examples of existing analog drum machines. There are common features that you'll see in many drum machines, such as the row of 16 sequencer buttons used for programming rhythms, a tempo control to change the speed of the pattern being played, and controls for modifying different qualities of the sounds produced. These real-time sound changes you can make are a big part of the appeal of analog drum machines. The early stages of the project involved development of the analog circuits via breadboard prototyping. Before construction of the final PCB, a prototype PCB was made containing only the sequencer circuitry, which allowed it to be tested on its own before combining it with all the analog circuits in the final product. Both the hardware and firmware aspects of the device were tested, and this involved things such as confirming the analog circuits produced an output that was in line with simulations performed earlier in the project, testing the firmware and MIDI implementation, and measuring the performance of aspects of the drum machine such as the sequencer's timing accuracy. After connecting power to the drum machine, a short startup sequence plays, after which the drum machine is ready to be used. The top display shows the current tempo, or speed at which a sequence will be played, which can be adjusted with this potentiometer, whereas the LEDs above each of the 16 sequencer set buttons show at which steps in the sequence each drum sound will be triggered. Currently the default startup pattern is loaded, which sounds like this. A more complex pattern I made earlier can be loaded by holding load and pressing one of the sequencer keys. A key feature of many analog drum machines is that different qualities of the drum sounds can be adjusted in real time. For example, I can change the length of the hi-hat sounds, or the pitch of each of the drum sounds, or the time that the bass drum takes to decay. I'll now load an empty memory slot and make a pattern from scratch. You can select the drum sound to edit by holding Shift and pressing one of the first 6 sequencer keys. In this case I selected the bass drum. A sequence can be built up while the sequencer is still playing. Now I selected the snare drum. I can save the new sequence by holding Store and pressing a sequencer key. I'm now going to chain 2 existing patterns together by holding Play and pressing the sequencer keys in the order I want the corresponding patterns played. The drum machine also allows for external control over MIDI. I'm using a program called Pocket MIDI, which is currently sending timing clock messages to the drum machine. I can remotely start and stop a sequence and set an exact tempo. I can also load different patterns. And trigger drum sounds individually.